I do find sometimes with this, when it's the sustainable conversations get going. Sometimes there's the assumption that people know what the opposite was. Um,
Yeah.
so can we back up? Let's go. I don't know how far back. Maybe we don't need to go 200 years back, but maybe 50 years back, 30 years back, sort of thing. What is the standard production process and power supply for steelmaking?
Well, the embarrassing thing is that we can go 800 years back if we want to. The blast furnace that is typically used to convert iron ore to steel was invented in 1300 something. But we can actually go 800 years back if we want to. The blast furnace that is traditionally used to make steel from iron ore was invented in 1300 something, and it has basically looked the same ever since. And that is also the reason that the steel industry today stands for somewhere between 7 and 9% of the global CO2 emissions. And that's not necessarily because we are bad at what we're doing, but the raw material that we're using, iron ore, is pretty much iron oxide. It's oxygen and it's iron. And in order to get to the iron, we need to remove the oxygen. And since the blast furnace was invented, that has been done with carbon, today in the form of coke. And what happens then is that the oxygen in the iron ore moves to carbon and forms carbon dioxide, CO2, as a byproduct. And we're left with the iron, which is exactly what we want. But this also means that for every ton of iron that you make with this traditional process, you get at least 1.5 tons of CO2. That's a chemical fact. That's part of the deal. You can't really do much about it. You can mess it up a bit more, but at SSAB, we have for a long time been very close to this lower limit, what is even theoretically possible with today's technology.
I just want to clarify another thing. Would that be the same with recycling? Like if you get a recycled steel, does it have to go through a similar, because it gets back to get broken down again then?
No,
No.
that is very much a better way of doing things. When you recycle steel, you put it in a huge bucket, pretty much, called an electric arc furnace, and you use electricity to melt that down to liquid form. And the great thing with this is that when you do that, you really break also the recycled material into atomic level. You really create a virgin material also from recycled content. So as opposed to many other materials, there is no aging in steel. Once you have dug up an iron atom from the ground and turned it into steel, you can basically recycle it forever. And this is a much more sustainable way of doing things. The only thing is that there isn't enough scrap in the world to do this for all steel. So you need to have both, basically.
I was going to say it's sustainable but not scalable at the level of new steel.
Exactly. The recycling rate of steel is quite high. It's 85, 90%, a little depending on where you are in the world. But since the steel consumption globally is increasing all the time, the recycled steel can't really keep up. The steel consumption in the world has almost tripled from the start of this century, from around 750 million tons per year in the year 2000 to close to 1.9 billion last year. And that is the reason that all the recycled steel in the world can only cover around 25-30% of the global steel demand today.